Hi everyone. After the debacle in class where nothing was working and we had all those issues, I felt I owed it to you to give you more instruction and guidance in how to complete the task from class today. I have a blank VEX VR project. I have the two repository files open. This is the task 1 template, and this is the on-off.py template that uses the on-off algorithm to drive itself to a certain location. And let's get started. Let's try some of this code on our own. The first thing is to take the template code and paste it into VEX VR. So I'm going to delete everything and just paste this in, and let's run the code just to make sure that it works as expected. Okay, so nothing actually happens aside from just the 90-degree turn. That's great. And so we are getting this error right here because in this function, I have called it diag distance. Let's try it one more time. So this means that the code now runs. Now, if you are watching this and you did not make that fix before, don't worry. By the time you see this video, I will have fixed the repository on GitHub so that that mistake is not there. So sorry about that if that's been an issue. Lots of issues today. Thanks for your patience. So the next thing, now that we know this code is running, I'm going to go to the main function and I'm going to comment out these other lines of code. And this is just because, as we've done all semester, when we're trying to solve a problem, it's good to fix each piece separately to make sure each one works on its own, and then combine them step by step in case there are any issues of combining them. So we're just going to do the X distance for now. I'm going to go to the control system example for the on-off algorithm. And the algorithm itself is really only in this part of the code. This is inside a while loop that just says, it checks to make sure that a timer has not gone beyond the amount of time that you want the code to spend trying to get to a certain location. So this is the only code you need. I can take that, scroll up to my drive X distance, and paste it in a similar location right under where it says your code goes here. There are some things that I can fix. We're doing the X location first. We're going to drive along the bottom of the grid first, so in the X direction first. So I'm going to change this to be X location instead of Y location. And this is just going to constantly check. It's going to get the new X location from the sensors built into the robot. If the X location is less than the set point, which is an input to this function, it's going to drive forward. If it is greater than the set point, it's going to drive backwards, and otherwise, it's just going to stop. So let's try this and see if it works. All right, so I'm going to take a look here, and we can see the robot starts here, it drives, it goes to -150 millimeters, which is almost to where we want it to drive to, which is X equals 0, so it's not quite there. So let's see if we can figure out why that is. So after some work figuring it out, I actually figured out that this amount of time, this 3 seconds, isn't enough for the robot to actually get there. So I'm going to increase it to 5 seconds, and I added a print statement up here, brain.print, and new line, so that we can actually see what it is reading as it goes. So it turns, and it drives, and you can see the position ticking down, and now that it gets to 0, now that it has enough time, it actually stops where we want it to stop. So we are set now for our first move. That's our first move, drive X distance. The next thing that we want to do, we can actually save some time now that we know that that piece is working, and re-enable this. I know that I want this to go for 5 seconds because it's driving that distance, and the 3 seconds definitely isn't enough. So now I need to do this for the drive Y distance. I'm going to use the same code as I used for the X distance. This function is using a set point as an input, so it's using that to know how far to drive. So I can just copy that over and switch this to be Y. This current position is going to be Y. I'm going to switch that. Everything else for just on-off control is going to be exactly the same. So this is going to turn to a heading of 0 degrees, and it should drive up to the Y coordinate of 0. Let's see how that works. Oh, and we get an error. Oh, I must have missed a current X location in my function. Where is it? Up, there it is. Current Y location, current Y location. Didn't find them all. All right. I also know now that this is working, so well, you know what? I'm going to leave that debug code in there. Let's just run it. So now it's driving up, gets to 0, and it stops. I'm just going to hide this so that I don't have to wait for it to load every time. And now that I know that that's working, I'm going to remove those comments. I'm going to take the print statements out because I know that those are working. And we'll close that. And let's show this, and let's stop it, and let's run our new code to see if it works. Oh, we didn't reset. Driving to 0 in X. That's good. 90-degree turn. You can see it bouncing back and forth. That's the on-off algorithm in action, so we know this is working. Now, before we get going, there is one last step. Let's review this video that shows what we're supposed to do and make sure we're on the right track. So there's the X distance, there's the Y distance, and now it's this last part that we haven't yet done, and we want to get to that location. So that location right there. Each one of these squares, I believe we're looking at, so since we're at 398 millimeters, we're basically going to the point 400, 400. But we're doing this at a distance that is at 45 degrees, so we want to end up at the point 400, 400. Now, for this requirement, we can actually use the X coordinate or the Y coordinate to guide the robot to its destination. It doesn't matter. So we can copy this code. So we'll paste that in. We need to make sure all of the indentation is the same. But the set point for this, like we know the set point is going to be 400. So we're going to do drive diagonal distance. The code is going to be exactly the same, but we can use either the X or the Y to do this. We're going to use, like I said, we're going to use the Y. So this should actually work. So reset, and let's run it. Okay, so it's at X. It goes to Y. And it gets to that location and stops. So we have done all of this with an on-off control. This meets the requirements for task 1. The next step to think about is how you might use a proportional algorithm to try to do this. So that's going to be the next video.